Hello, everyone.
Hey, everyone. Can you hear us OK? Nice to see you all. Let's get started. Easy. Right. Hi, everyone. My name is Ignas. I'm a senior staff engineer at Vinted, responsible for platforms of Vinted Marketplace.
Hey, welcome once again. I'm Ilvinas. I've spent quite a few years shaping Vinted Ghost technology, and now I just recently switched to building distributed security systems for the marketplace.
So we are here today to tell you a story about scaling Vinted, how it went from a successful second-hand marketplace application to a Europe-wide distributed system with an ambition to grow even further. For those of you who don't know Vinted very well or didn't pay attention during our awesome video with 7,000 servers, Vinted is a technology company that is building the future of second-hand. We have a connected marketplace operating in most of Europe at this point. We're loved by millions of our users. We have our own shipping company. We have our own payments company that helps make payments safe and secure for our users. And as a company, we're like over 2,200 people. Bigger half of that are people who are actually building our products. Engineering alone is around 800 people, and some 600 of those are developers like myself, Ilvinas, and hopefully a lot of you in this room. And Vinted is on a mission. The mission sounds simple: make secondhand first choice. It's ambitious, it's beautiful, but of course the focus of our talk here today is going to be on the engineering of it all. So the story we want to tell is essentially about architecture and how it evolves in a successful company like it did at Vinted, with business plans and product goals never standing still and demanding an ability to ship yesterday, basically.
So today we're going to tell you our story in 4 chapters. So we'll begin with the foundations that we believe really shaped us as a company and enabled our growth, about which we'll talk next. And this growth already meant certain challenges that we had to face, and we will cover those challenges, and we will tell you how we actually attacked them and how we dealt with the newfound traffic peaks, as well as new reliability requirements. And finally, in the last chapter, we'll give you the sneak peek into the next challenges that are ahead of us, which will truly push us towards operating on a global scale. So starting with the foundations, some of you probably know that Vinted pretty much from the day one has been running on on-premise infrastructure. That really over the years grew into our own data centers and allowed us to develop really deep technical expertise in the matter. This expertise in general and the skill that we developed lets us keep tight control over costs and really allows us to decide how we scale, when we scale, what technologies we use for it, and really have very, very strong grip on it. Just curious in the audience, are there still people running on-premise? Maybe raise your hands.
Okay. All right, that's a good 10% of the room.
Yeah, we're on your side. We really, to this day, still stand strongly behind our decision here, especially after having a look at the cloud costs these days.
So Vinted was born as a Ruby on Rails application back in 2008, for those who don't know the history. And as was customary back then, it used MySQL as its database. And it was all fine and dandy for many years. And only at around 2018, 2019, we started approaching the limits of vanilla MySQL. That's when we started the effort to adopt Vitess. It's an open source database clustering technology that manages large MySQL deployments, basically. What it gave us is high availability of our databases and near unlimited scaling by sharding the data in smart ways. So it's now able to handle billions of listings that get uploaded to our platform per year. And we went deep and strategically invested in this technology. We have experts in-house who are able to scale our databases really well. We even contribute back to the open source project of Vitess.
And we even have them in our booth there. You can talk with them about this if you're interested. Another cornerstone of our engineering culture, I would say at this point, was pretty much from the very early days continuous delivery that we adopted. And that means today we ship to production thousands of times a day, every day, including Fridays too. We are not afraid of that there. We are strong proponents of failing fast, shipping fast, iterating, repeating, and we really believe that this was something that allowed our organization to grow as rapidly as it did, as well as our business to scale as fast as it did.
And finally, with running our own infrastructure came a strong site reliability engineering mindset. Reliability is a first-class citizen at Vinted. We use SLOs to keep us focused on what matters most and provides data to us for decision-making. We automate as much of our operations as possible. So as we strive for that operational excellence, the goal is not only to provide a strong platform for product teams to build their services on top of, but also we're aiming to foster a strong culture of ownership where teams are designing, building, operating their services themselves autonomously. So those are our 4 foundational pillars that kind of enabled a lot of the early success.
Yeah, probably besides other things, but this is what we thought was really the key things. And really strong foundations meant naturally rapid growth that we were experiencing. And namely, we were really, from 2018, it really got into traction there. We were launching new countries multiple times a year, putting them into our shared European market, which we managed to create in just a few years. So after that, we really had this pan-European marketplace where people were being able to trade cross-border, ship, get our support, and really this led us to also acquiring other marketplaces and platforms that we integrated into our marketplace. And later on, as this whole thing was happening, our user base really exploded. We got billions of items listed every year, and this naturally created some more movements in business. We opened our own logistics company, Vinted Go, of which I had really a great chance to be part of. And yeah, this was really, really exciting. But at the same time, we were noticing something. All this traction, all this movement, all these developments, there were more and more and more. It was never stopping. And we see, it seems like we aren't able to keep up with this appetite. We probably need more hands. So we thought, yeah, let's get more people. And we hired more people. We hired a lot of people. In fact, we were doubling in our engineering headcount several years in a row, as you see there on the graph on the right. However, the expected change never arrived, even after several years of doing this. We saw that really our shared code base was not getting more contribution somehow. It was even showing signs of slowing down. Something was not right. Probably that wasn't the right solution that we were going after. So we stopped once again and really realized this was growth that outpaced our architecture. We needed to do something about that shared code base that we had because it was becoming the bottleneck.
So in a kind of enough is enough moment back in 2021, our principal engineer, Raimondas, announced that, okay, backenders, it's time to break up the monolith. So here, we're going to tell you a little bit about how all that went. Modularization as a concept is many things, but it's not one that is easy. We thought we would be smart about this and kind of plan for it in advance. and execute in several stages. The first step would be to like, hey, we have this we have this monolithic code base. It's been evolving for like 12 years, 13 years at that point. Imagine a single application written in Ruby, developed by hundreds of developers by that point over 12 years. There's a lot. So hey, can we like maybe improve team autonomy and their development velocity by restructuring the code inside the application as a first step? We didn't want to introduce the overhead of like actually learning how to spin up a new service for each team and then start operating, start on call to monitor it, and so on and so forth. So like, yeah, let's modularize in place. What we want from that first stage is like, well, let's reveal the seams between the different domains of the product. Let's kind of start stabilizing contracts. Let's see what the APIs of things would be if we were to split them eventually. So we mandated our developers to like, hey, let's start building facades for all the different pieces of data that still live in the monolith. And we thought by doing this kind of early and starting in place, the process would be cheap. Turned out it was, at best, cheap-ish. A little bit more detail on the approach, right? We are reorganizing our monolithic code into modules. In Ruby, modules are either Ruby gems, which is a library, or a Rails engine, which is a more complex module pattern. But ultimately, you can just kind of put your code into directories and introduce some rules about one module accessing another. And there's a framework for that called Shopify Packwork. Kind of define your module rules, you define access rules, and it can help track your stuff. We wanted those modules to be full vertical slices, including data. So starting from the UI, ending with database access, all the code should be clearly defined as a single module, and then communication between those modules should only happen through their facades as a public API. It was very important to keep track of this. Like, how do we know we're making good progress? So we actually annoyed our developers a lot by introducing those architectural fitness functions into our CI pipelines. If you breached modularity rules, you would get a warning or an error. And very quickly, modularity violations became #1 headache for Vinted developers.
So we were several years into the job. It wasn't an easy one, but luckily, quite fast, we started noticing some positive trends. This is the picture that we're showing is the general throughput of how much stuff we actually shipped into production every month. This was finally going upwards. Of course, this is not enough to give you a full picture. There are many more other metrics that we have. We also do qualitative metrics like developer surveying, all of which were also trending upwards in terms of code-base satisfaction and the perceived velocity of delivery, which was really motivating us, and we kept on going. We had first results, which were great. We had a solid plan, like Ignas told you. Everything was quite cool. And we actually structured this code base, only to discover that once we put it in place, there was just the tip of an iceberg. Once the boundaries were there, thousands of violations started poking us. Yeah, it was a headache, but then it was, I don't know what it was. It was something worse, I think. Yeah, so we also had, we created those modules. We put the APIs in place, but we didn't really realize that those APIs were simply workarounds now to get the same stuff from the module through the API that we used to get directly. So it arguably even became more complicated. We were also passing God objects around, which were just, imagine, like manager object, user object, transaction object, everything. It's in there, hundreds and maybe thousands of things inside. So those had to be broken apart. And those contracts were really not that well defined. It was just like I mentioned, just workarounds most of the time. So we needed to fix it all, besides restructuring Codebase. And we are still working on it. We are in a much, much better place. We're still nowhere near the finish line. But it is generally something that we'll keep on doing and really think this is valuable and should be done. Yeah, so we got faster. Our code base was nicer. We finally had at least ownership everywhere, which was already a huge achievement. Yeah, but while we were at it, the systems never really stopped business was doing new things. We needed more new things. Everything was growing in complexity. We started, getting new traffic peaks every year that we never saw before, like you see here. And it's not like we never had incidents. Incidents are our daily job, but these incidents were becoming a bit more impactful. They were costing us more, and worst of all, they were having bigger and bigger blast radius. More often than not, the whole Vinted would go down, which was pretty big. And this screenshot of an incident here that I'm showing is kind of like sad and funny at the same time. So it's sad because Vinted is down, you cannot trade on it anymore. But then what's funny, it also brought down the whole incident management software. So, I don't know, is there a problem? All right, so this was scale this time that really caught up with us. And this was scale this time that made us think again, damn, our architecture is again not good enough. We need to think once again. Huh?
And so we did. We sort of knew when we started the modularization journey that, one day we would be putting code in services. Of course, that's what you do in every medium to large software company. You build services. So it was time for us to start doing that. In the previous step, we kind of introduced facades, defined APIs of modules. It was time to hey, let's put the code physically in a separate service and start thinking about the distributed service architecture. Being experienced developers as we are, of course, we knew that, we don't want to go from a monolithic big ball of mud to a distributed microservices hell. So we had a plan. Let's build coarse-grained services. They're not going to be too small. There's not going to be thousands of them, just the right number of services of just the right size. Each service should be its own failure domain, so if it goes down, the rest of the system doesn't go down. We can scale them independently, handling throughput as needed for each service. And then we would, of course, introduce team-level accountability and processes for availability of their services. Teams would start having on-calls. There's clear boundaries of ownership, who wakes up in the middle of the night to take care of the incident. Kind of the modularized monolith was the foundation for this. Take the APIs that we defined in-app, in process, and move them into separate services. We even, at that point, decided, OK, it's time to sprinkle on a bit of event-driven asynchronous communication between services. And so we did. And, what do you know? Completely unexpectedly, we ended up with this. Hopefully, it rings true for some of you in the audience. Eventually consistent distributed monolith is what we got, because we quickly started realizing that it's not enough to split the code.
Yeah, it wasn't that bad, was it? But so the realization that came, like I said, so remember, those modules weren't having that great of APIs in the first place. So now imagine them made distributed suddenly, right? So the real monolith that was hiding underneath was the shared database that we had. And we didn't pay enough attention to really split it and design it properly in the first place before jumping into services. So we had to do it while we're at it. And coming back to all these failures and incidents once again, you know already pretty well that one slow query on a monolithic database means that no matter that you have all those services deployed separately, when it goes down altogether. So all the benefits are lost, and you're back at it, right? So we needed to split this data, and very importantly, we needed to find very, very clear exclusive owners of that data. If you write it, you're responsible for it. The rest of you may not touch it at all. So we'll tell you how we approach this in general. Like we mentioned in the foundations chapter, we already had Vitess in our tech stack for quite a while back then. But then we also had experience in sharding it. However, our efforts were rather reactive. We were reacting to pressing performance issues or storage limitations that we got. And so we would sometimes take whole tables or columns of those tables and just move them into a separate physical shard or a separate physical database, in other words, that we would call vertical sharding. Sometimes tables would grow so big that you would need to split them by rows. So we would just shuffle rows across different shards that we would call horizontal sharding. And sometimes where matters were that bad, we would do both at the same time, right? But this time, the problem was a bit different. It wasn't really performance, it wasn't really storage. We had to be very strategic this time. It was about actually redesigning our whole database and splitting it now along the business lines, along the service lines that we created or were creating at that point. And this led us to one, I would say, very important technical decision that we made, was this creation of a functional shard or a virtual shard, which means that before ever going into like a split physical situation, which wasn't that needed at that point, we would put virtual boundaries around our data, and then this way already virtually enforce this. I will show you what it looks like in more detail if you're curious. So on the left here, you see two modules, green and blue. Both of them are actually talking with the same physical shard or the same physical database. But then we put those virtual ones, virtual shards in place, and we structure the data, like move the tables around and put them manually into individual functional shards. And this way we put the fence around it, and whenever module 1 tries to reach for the tables that are not in its possession, then there is an error that we put in on our continuous integration checks, and people have to fix it. It could act once again as a fitness function for us to make sure that our architecture is evolving in the direction we want it. It looks simple. There were other problems. We will talk about them. But this, in fact, led us into actual isolation of things. So there were no longer queries that were joining across shards, albeit functional. There were no longer wheres or subselects that were hitting other tables. At least we had some sort of, if there was coupling, it was no longer on the schema. It was now on the API, probably. And this allowed us to do the situation on the right, where you see now, for example, services that are actually interacting with physically separate data. And then we were focusing now on the software level to solve all the couplings and the API design problem. Yep.
And at this point, we were starting to feel pretty good about our architecture. We have services, they're not too micro. We are decoupling our databases. Asynchronous messaging is starting to become a thing where we handle some processing kind of in synchronous fashion. And just as we were getting comfortable, ambition changed one more time. In 2025, Vinted's mission evolved from this to this. We now want to make secondhand first choice worldwide. And we're starting to test like the business of it all, the operations of it all. But as engineers, when we hear worldwide, we start thinking one thing: speed of light. Of course, the problem of speed of light is if you try to go faster, you can only live in darkness. So let's talk about the speed of light. Now, speed of light becomes the issue that like challenges our architecture in a great way. Yes, so far we have a distributed system. We have multiple data centers in Europe. They're close to each other, 5 milliseconds between them. We have decoupled databases. We do asynchronous business events. Like all the ingredients of a distributed system are there. But in practice, so far we were in easy mode. Like those 5 milliseconds can mostly be ignored, and we were not really facing eventual consistency in any meaningful way. Meanwhile, on the map, I have like random locations in the world in far continents, and you get at least 100 milliseconds of additional internet latency if you try to put a server anywhere else in the world. 200 plus for even further regions. We needed to think about this. Like, how are we gonna operate globally? We assume we want to put servers somewhere. How is it all gonna work on the architectural level? So, and this is recent, we're still thinking about this, so more hypothetical than not. First phase we envision as, let's have the ability to put an edge site anywhere in the world. An edge site, the way we define it, is a site that where we can deploy services that do read-only serving of data. They have the data available locally in the site, and they respond to read queries. So this forces us to kind of think about actual eventual consistency in a meaningful way. We are talking about like CQRS is split between reads and writes. Reads can happen locally. Writes for now will go back to our central site in Europe. We have to think about optimistic UIs. Sometimes there will be a delay, and we will maybe be tricking the user in thinking everything went through, but actually it will only be done a second or two later. We need to talk about graceful degradation, because well, what if one site is not responding while the other is still trying to serve the user? So all of those issues suddenly became the reality. In its early days, we're thinking about it hard. It's exciting. As engineers, we have a lot of new things to do.
Yeah, and I don't know about you in the audience, but how is it for you listening? But for me, it's getting increasingly more complicated to tell the story of how complicated it's getting. But hold on. This is like, how do we even talk about building a global system here? Maybe, so our idea was maybe let's descend from the outside and go a little bit deeper, like how it operates. So let's start with the API gateway, the cool guy here. This is where our traffic from the members and from our apps and clients actually enter this global system that we're after. So I'll tell you a little bit about how it came to be and how it's actually working at this point in time. So initially, it was supposed to just help us deal with the microservices that we were building, the coarse-grained services that we were building, and really route traffic inside of it. But it suddenly got a new meaning. Now it's a global routing system that it has to be. So here, we show you like a pretty rough architecture of it. On top of it, you have everybody's favorite CDN, like Cloudflare for us, for example, which routes read traffic to the edge side on the right, which is read-only, and then all the read traffic that must be strongly consistent, and the write traffic, it's going to the central side on the left. On both sides, you have a north-south gateway, which besides many other things is doing also routing, which we're focusing on here. And then traffic enters insides of the site. Both on the central and on the edge side, you have the Istio-based service meshes, inside of which services are talking with each other in isolation from the rest of the world. And whenever there's a need for this edge site, for some reason, to write something, for some internal purposes, for example, or whenever there is a must to have the freshest data from the central side, then we ought also place this east-west gateway for this kind of sub-site communication that sometimes is needed there. And you know what's also very exciting about it? We're building this thing ourselves because we couldn't find anything that would suit our needs for this purpose. And this is what it's looking now. It's built on a bare metal machine. It is Envoy-based, and it is currently, as we're speaking, is already handling comfortably on only 5 machines, around 10 to 15% of our peak traffic that is coming to the Vinted marketplace, which, if you ask me, is pretty exciting, and we're really looking forward to where this leads us.
But of course, it's not enough to put some services in an edge site and make sure the user requests get there. The services will need the data. We promise that the data for reading purposes will be there available for fast serving. We need to ship the data, overseas, as it were. At the same time, we don't want to just copy all of our data. Like, there's too much of it. We said before, we did a lot of work to decouple, assign ownership, and so on. So we want to be smart about it. How do we figure out what data the service needs for read scenarios? How do we take only that data? Maybe we need to transform it, filter it, aggregate it, join a few data sources, ultimately own a copy of data that the service needs. We're calling that a data projection. So to do this properly, we're building our own asynchronous, event-driven data projections platform. I have a short story about how this kind of goes from beginning to the end. Let's start with a source database. Maybe it's been sitting there for 15 years collecting our item data or user data, transaction data, anything like that. It's not typically, all of our data, as we said, is in Vitess, sits there, works well, does its job. It's typically owned at this point by a service, let's say service A. Maybe it's one of our older Ruby-based services. We did extract some Ruby code into services and didn't just keep Ruby in the monolith. So now we want that data for another service's purpose. Of course, we choose to do this asynchronously. We say like, hey, service, please emit business events about the entity that you own changing. We put those events into Kafka naturally. To produce those events reliably, we adopt an outbox pattern. This is kind of a synchronous messaging 101. And data starts flowing. Then a consumer service that needs the data, maybe it's one of the newer Golang-based services that we are writing more and more of, can simply listen to the stream of events, take what it needs, write it into its own database as a projection of the data, and it's ready to go. Now, we all know on consumer side things can also go well. We need to be reliable, so we have this pattern of introducing some additional helper Kafka streams for retry rather, and dead letter queues. And together, this is like your pretty robust generic asynchronous messaging setup. You rely by produce events, you rely by consume events, and data starts flowing. Of course, for our scenario that we're talking about here, for data projections, you need full historical data. One of these services might be 10 years older than the other, so like, where's the history? For that, we are building a dedicated system for event ingestion and playback. So every event emitted by every service, potentially, at least the ones that we do actually need to keep history of, we record. So the system is basically built on Apache Flink. It's massive parallel processing of Kafka topics, and we write those events into our event store, which is based on Apache Iceberg. So that gives us a full history of events about every entity that we care about. Now, when the consumer service B is finally ready to like build the full projection, all it has to do is subscribe for a replay. A magically additional Kafka topic appears, gives you full history. It's typically a one-time process. You ingest it all, and you have your full data projection. At this point, a tiny, minuscule thing left to do is, I don't know, take the gigabytes of historical data in the source database, do a one-time load job, transform that data into events, load it into the event store, and that completes the picture. We have everything we need to create a data projection, which is a smart copy of just the data that the service needs to survive. Oh, and then the projection table, we can replicate it overseas easily enough. The important part is like getting the data that the service needs. There's one sticker that's missing from this slide, which is like, are we really putting this data back into yet another Vitess table? For now, the answer is yes, but it's an uncomfortable answer, and this really makes us think about that we will need to evolve our database technology, but that brings us to the next slide.
I really like how you said, and this is only what you need. I like how humble you are about this. This is just a very simple thing that you need to do this whole edge-ready data replication in Vitess. But so I really have a feeling that this is very, very soon not going to be enough. Like this simple solution is not going to suffice us anymore because so we need now just read-only edge sites, but it's pretty clear that if that works out, we also will need our members to really enjoy a seamless checkout experience all over the world. And for that, reading is not enough. You need to write things. You need to make things probably also consistent because it's money and stuff, right? It's just we cannot afford that. And so what this puts in front of us is a set of really difficult trade-offs that we'll have to make. Where do we put on this cap Venn diagram? Is it that we're after consistency really most of the time, or is availability for us important, or do we do everything everywhere all at once, right? It's just something that is really there. I think it's not even maybe years ahead of us. It's probably very, very soon. And it's not just those trade-offs. It's not just storage technology. It's a lot of things that's coming with it. So we're going to have to forget. We're already forgetting this anyway. Those really convenient, reliable transactions that we enjoyed, forget it. Not there, gone. You need to think now in some workflows and sagas. You need to think, how do I fix a problem that has been broken several times in a row and maybe is stuck in this 15th branch that it was going through to complete their checkout process. But then this complexity will have to be hidden by doing really sophisticated, solutions and architectures there. And we also will need some new storage. Vitess is obviously not going to suffice us there, but what are we going to use for that? Where will we put this storage system in our requirements? Maybe there will be multiple, we don't know. What we know for sure, that this is pretty much something that's going to be there very soon, and we will need to think and stop again and probably redesign the whole thing once again. Yeah, I don't know about you. I'm pretty much ready for the challenge.
Yeah, it sounds like there's more and at least one more time architectural rethinking of Vinted. So hopefully we convinced you today that Vinted is a technology company. We invest heavily in the technical foundations of how our business works. And our systems are built by our people. And those people solve those interesting problems that we just talked about. It's engineers who understand distributed systems. It's SREs who will open a data center anywhere in the world. It's database experts who will build our new database layer that supports consensus. It's product managers who think in eventual consistency. They understand that you cannot just tell the user the immediate state of something that happened 10 milliseconds ago. We have designers who embrace graceful degradation, and they understand that sometimes we need to deal with fault cases. These people and many, many more will be building that future global marketplace that we're so excited to design. Perhaps join us. We have a booth outside. Come talk to us. Thank you so much for your attention today.
Thank you.